It began as a whisper from deep space, a molecular footprint buried in starlight, unnoticed at first, then slowly, almost reluctantly, revealing its impossible message. In late 2023, NASA's James Webb Space Telescope pointed its gaze toward a distant planet KTO-8b, a world orbiting a dim red dwarf 124 light-years away in the constellation Leo. What the data showed could be the most earth-shattering revelation in modern science: chemical traces in the atmosphere that on Earth only life has ever produced. Specifically, a sulfur-based compound known as dimethyl sulfide, or DMS. The shocking part, there is no known non-biological way to produce this gas, at least not one we've ever observed. And on Earth, DMS is the scent of life created by plankton, by decaying organic matter, by microscopic engines of the biosphere. Now, this molecule may be floating above an alien ocean. But before we jump to conclusions, let's rewind. The strange behavior of this signal didn't match normal planetary chemistry. It wasn't where it should have been, and it was far too weak to be noise. Scientists at Cambridge confirmed the signature using not one, but two different instruments aboard the Webb telescope. First, near-infrared, then mid-infrared imaging spectrometer MIRI. The result, an unmistakable confirmation not just DMS, but also its chemical sibling DMDS. And both are biological markers. Yet the discovery has sent shockwaves not just for what it revealed, but for what it implies. Because if this signal is real, then something on K218b is alive. This isn't a gas giant. It's not a frozen wasteland. K218b sits squarely inside the habitable zone of its star. It's more than twice the size of Earth, and likely covered in deep, dark oceans. If conditions are even remotely similar to our own world, then this discovery might not be theoretical. It might be biological. Life out there. It's the question humanity has asked for millennia. Are we alone? For decades, the answer was silence. But now a whisper from a distant ocean world might be breaking that silence. Could the green flash of DMS in KTO-8b's atmosphere be the first signal from an interstellar biosphere? And if so, what does it mean that this molecule, the same one that gives our oceans their scent, is drifting through the skies of a distant planet? Have we found a twin to Earth or a shadow of something far older and more alien than we ever imagined? One thing is certain. This isn't a false alarm. It's not conspiracy. It's real data. And it may force us to redefine what it means to be human and what it means to be alone. The search for extraterrestrial life has always lived in the tension between signal and silence. And with the case of K218b, it all started with ambiguity. The first detection of dimethyl sulfide DMS came through Webb's near-infrared spectrometer, NIRSpec, in 2023. But the signal was faint, overlapping heavily with methane absorption lines, making it nearly impossible to separate the two with high confidence. That meant either a hint of alien biology or nothing at all. And that's exactly why the James Webb team turned to a second method, the MIRI instrument operating in mid-infrared wavelengths between 6 and 12 micrometers. This is where things changed. In two distinct bands, 6.88 and 911 micrometers, Webb registered sharp peaks precisely where the spectral fingerprints of DMS and its cousin DMDS should appear. This time, there was no mistaking it. The statistical confidence of the signal hit 322 sigma. In layman's terms, a 99.7% probability that the molecules were really there. Not an error, not noise, not a glitch. These are molecules that here on Earth only biological organisms produce. What's more, the concentration levels were off the charts, over 10 parts per million, about 1,000 times more than what we find in Earth's atmosphere. That intensity suggests not just presence, but prolific biological activity. And if the models are correct, the atmosphere of K218b may be rich in hydrogen-trapping heat and creating a greenhouse environment ideal for microbial life beneath thick clouds. This could mean a global ocean teeming with microscopic alien organisms, analogs of Earth's plankton breathing, reproducing, releasing trace gases into the sky. Still, the science remains cautious. For a signal to be declared a true discovery in astronomy, it must hit 5 sigma, a 99.994% confidence threshold. Webb's readings haven't yet reached that, but they're close. In fact, a few more hours, just 8 to 24 hours of additional observation time during K208b's transits across its star may be enough to break that barrier. The clock is ticking, and the next data window could confirm what humanity has only dreamed of for centuries. Yet even amid the excitement, the scientific community remains divided. Some astrophysicists warn against declaring victory too soon. Why? Because DMS has also been found in trace amounts on comets. And while we don't know of any purely abiotic pathway that can produce it in high quantities, absence of proof is not proof of absence. Could there be exotic chemical processes unique to K218b's environment that mimic biology? Possibly. But so far, none have been demonstrated in lab or model. So the mystery holds. And with it, the weight of something profound. Are we looking at a signature of alien life, or a cosmic trick played by unfamiliar chemistry? The Webb telescope, the most powerful space observatory ever built, may soon force us to choose. For a brief moment, the scientific world seemed unified in awe, but that moment didn't last. While Cambridge researchers hailed the DMS detection on K218b as a potential biosignature, other voices moved swiftly to cool the fever. Skepticism didn't come from conspiracy theorists or denialists, it came from inside the house. Astrophysicist David Kipping of Columbia University was among the first to remind the public it isn't exclusive to Earth's oceans. It's also been detected in trace amounts on comets, frozen lifeless relics of the solar system. If cometary processes can create DMS, couldn't an exotic planetary environment do the same? Even more damning was the release of a separate U.S. research paper just weeks after the Webb data dropped. Their conclusion was unsettling, might not be a life-harboring water world at all. Instead, they argue it could be a searing inferno, a molten giant cloaked in a dense hydrogen atmosphere, more magma than ocean. In that scenario, DMS might emerge not from microbial life, but from extreme geochemical reactions. Reactions we've simply never seen before. This interpretation threw a wrench into the life on K218b narrative. After all, it wouldn't be the first time excitement outran evidence. We've seen biosignatures before Mars methane, phosphine on Venus. Each time, hopeful headlines gave way to scientific walkbacks. But here's where things get trickier. Even the lava planet theory doesn't yet explain the sheer abundance of DMS and DS. On Earth, these levels would require massive biological output, far beyond what any abiotic process is currently known to produce. And therein lies the conflict, two opposing models, each incomplete. One requires biology to explain the data. The other demands unknown chemistry. Neither side can yet claim certainty. But here's what makes K218b different from past false starts. This time, the detection is repeatable. And this time, too, two independent instruments recorded the signal at separate wavelengths. This time, The data aligns with what models predicted for so-called Hycean worlds, a theoretical class of exoplanets that are larger than Earth, covered in oceans, and wrapped in hydrogen-rich skies. Hycean planets, according to recent studies, could be even more suitable for life than Earth itself. In these dense atmospheres, biogenic gases like DMS can accumulate to detectable levels. And unlike Mars or Venus, which are either dry or toxic, K218b might be, if it is what it seems, a global crucible of life. Still, for every voice calling this the greatest discovery in modern astronomy, another urges restraint. Is this the long-awaited answer to the Fermi paradox, the silence of the stars finally broken? Or are we staring into a funhouse mirror, seeing reflections of life where there are none? The truth may lie not in the chemistry, but in our interpretation of it, and that's the hardest part of all. So let's say for a moment the optimistic case is right, that the DMS detected on K218b isn't a chemical fluke, that it truly originates from a thriving biological process, microbial oceanic alien. What would that mean for humanity? The answer isn't simple, because we've never encountered something like this before. Not in all our years of radio silence, not in the tangled math of the Drake equation, not even in the golden records we launched into the void aboard Voyager. If confirmed, this would be the first time in human history we've found hard physical evidence, a measurable signal suggesting life beyond Earth. And not intelligent life with ships and signals, but life at its root, a biochemical echo from an alien sea. The implications would ripple across every field: biology, theology, cosmology. Our concept of life would stretch. Our place in the universe would shrink. Suddenly, Earth is not unique, just one of many homes where molecules learned to replicate, to evolve, to become conscious. But that's assuming the finding holds up. And it's not just about one telescope or one planet. K218b is only 124 light-years away, close in cosmic terms. And if it harbors life, then the galaxy might be teeming with it. But here's the unsettling twist. If life is common, why haven't we seen more evidence? This is the old paradox. Reborn. Enrico Fermi's chilling question still echoes. Where is everybody? If we're detecting signs of life now, why the long silence before? One theory: life never becomes intelligent. It flourishes in oceans and dies there. Another civilizations collapse before they can reach out. Or perhaps the darkest thought intelligent species stay silent on purpose. Maybe they've learned what we haven't, that broadcasting your presence in a hostile galaxy is a mistake. And yet, we've already done it. The Arecibo message, the Pioneer plaques, the Voyager records. We've been shouting into the void for decades, hoping someone's listening. But what if someone already heard? What if something more advanced already knows we're here? As Webb continues observing, scientists are racing to refine their models, confirm their signals, and answer one terrifying, exhilarating question. Are we finally on the verge of proving we're not alone? Or are we chasing ghosts through the static? The James Webb Telescope has lifted the veil. The data is coming. The numbers are real. But meaning is something we must interpret ourselves. So now, it's your turn to ask the question. If life truly exists on K218b, are we ready to meet it, or terrified of what it might mean?